Now we'll deal with hypothesis tests that involve two lists of data, and we are intended to look at the differences between the data. Now in this question, a local pizza restaurant is close to a college campus. They advertise their delivery is faster than the local competitor of a national chain to the college dormitory. 10 statistics students decide to test this claim. Each chooses a time and calls both restaurants at the same time, and times the delivery of both. The results of delivery time in minutes are in this list below. Is there enough evidence at the 0.01 level that the local store does deliver to the dormitory faster than the chain store? Now let's try to write a claim for this. The wording of the question doesn't make the claim entirely clear. However, we can say that our difference will be the local minus the chain. Now, if it's true that the local is faster than the chain, then this should be negative because supposedly, according to the claim, we're taking a small number minus a big number. So I'll write that down. If the claim is true, the difference is negative. And another way to express negative in math is less than 0. So we can say that our claim is that the difference is less than 0. We represent the difference with the symbol mu d. This means mean difference, and say that it's less than 0. However, this will be the alternate hypothesis, so I'll come down a little bit and rewrite it. Now we have our claim, and now we write the null hypothesis as the opposite. Now, we'll have mu d greater than or equal to 0, which is the opposite of less than, remembering that the null hypothesis must contain equal. Also, let's decide what type of test we're doing. Because the alternate hypothesis says less than means left tail. Now let's write about our possible outcomes. Now, if big P is less than or equal to alpha, that means we would reject the null hypothesis because you have strong evidence. We would also say that if we did cross out the null hypothesis, we would support the claim. However, if big P is greater than alpha, that means we would fail to reject the null hypothesis. And once again, the reason why we would not reject the null is on lack of evidence. This means that we do not support the claim. Now, in order to calculate the test statistic, we have to start by finding the differences between the local and the chain. As we've said, we'll take equals, local, subtract chain. So we'll click on the first item under local and subtract the first item under chain and press enter. This gives us a difference of negative 5.2. We can take the black cross, put it on the corner of this box, and autocomplete all the differences. Now that we have a list of differences, we can find our sample mean, our sample standard deviation, and the size of the sample, all based on these differences. Now be careful here. You might be tempted to use the local and the chain values to calculate your test statistic, but that's not a good idea. It's better to use the differences we just calculated. Now, to calculate our test statistic, we'll use d bar minus mu d divided by SD divided by square root n, where d bar is the mean of this list of differences. Mu d will come from the claim, SD will be the standard deviation of this list of differences, and n will be the size of the sample. Now, once again, we would only look at the differences here. Now let's make a place for these. We'll say d bar mu SD, and N. For D bar, we'll use average of the list. For mu, we will use the claimed mean. For SD, we will use equals stdev.s of the list. And for n, we will use equals count of the list. So we'll say equals average and select our list. For mu, we use the mean from the claim, that's 0. For SD, we will use stdev.s and select the list again. For n, we'll use count and select the list one more time. Based on this, we can find our test statistic T. For this, we'll use the equation equals d bar subtract mu divide by parentheses SD divided by square root of n. Close the parentheses twice, and we get our test statistic. Now let's make a little more room and try to calculate big P. So we'll have a left tail, a right tail, and a two tail. Now this time, our alternative hypothesis was left tail, so this will be the answer we need, but again, I will demonstrate how to do all three in case you need them. To get the left tail, we say t.dist, click on the test statistic, comma, n-1, comma, true. This gives us our left tail value. For the right tail, we say equals 1 and then subtract the left tail, and then the two tail. We'll say equals 2 times minimum of the left and the right. We select them both, press enter. Now the left tail is the value that we need, and we need to compare that against alpha. So our big P was 0.00696. Alpha is 0.01. We can tell that P is a bit smaller than alpha. Therefore, we can say because P is less than alpha, we would reject the null hypothesis and then support the claim. So, scroll up, cross out the null hypothesis, and we will support this claim. Now, the claim was that the local chain is faster. So we'll say there is sufficient evidence at the 0.01 level. Now, we've decided to support the claim, and let's restate that the claim was that the local chain is faster. So we have mentioned the evidence, we've mentioned the significance level, we've supported the claim, and we've talked about that, and we have restated what the claim is. Those are the 4 things we need to say to draw a conclusion.